In this video, I'm going to talk about factoring, quadratic formula, and completing the square for quadratic equations, and solving them for x-intercepts and zeros, and finding the roots. Okay. First, let's talk about factoring. In the very beginning, we talked about factoring when a is equal to 1. And for those cases, it's very simple to do. So for example, let's say that I have a question, m squared minus 9m plus 8. This is a classic case when a is equal to 1. Now when I say a means the first coefficient, or the leading coefficient. As long as that's 1, the factoring should be very simple, and you can do it right away by writing those two parentheses down. Here and here you would put m, and here and here you would write two factors that multiply to give you c, and then those two factors have to add to give you b. When I say a, b, c values, it just means the a, b, c values from our standard equation, ax squared plus bx plus c. So in this particular case, a would be 1, b would be negative 9, c would be positive 8. It has to also come along with the signs. So if it says negative 9 for b, that means that it's the whole thing, the whole negative 9 has to be the b value. Now, the two factors that multiplies to give you c, which is 8 in this case, those two numbers could be many different ones. It could be 4, 2, it could be negative 4, negative 2, and the order also matters here. It could be one of those four, or it could be even 1 and 8. So there are a lot of possibilities in which it could multiply to 8. Now, the way to solve for which one of these following is going to be possible is going to be by looking at the second category. Two factors have to add to give you b. The only value that will add to give you negative 9, which is your b value here, would be this, negative 1 and negative 8. Now for this, the order would not matter. So if you write it this way as well, it wouldn't matter, because if you write it n minus 8 times n minus 1, which is this one, or if you want to write it this way, it wouldn't really change the fact that it's going to be the same. But later down the road, when a is not equal to 1, the order in which these things are located matters significantly. So your answer will be either n minus 1 times n minus 8 or n minus 8 times n minus 1. Pretty simple. Now in the beginning, when you're trying to do factoring, this way, just starting off with parentheses will be the way to go. Whenever I ask you to factor something, it will always be to use it for two parentheses. You have to write down two parentheses, and you have to write down the first two factors, x and x, or in this case m, and these two have to multiply to give you the last c value, add to give you the b value. Okay? So when a is equal to 1, it's fairly simple. But when a is not equal to 1, that's when it starts to get a little tricky. Now, in the very beginning, we struggle with this a lot. But with a lot of kids, what they worked with the best is called the AC method, or called the grouping method. Aside from those, there were some kids who like to use the boxes, or just straight up use the parentheses. Those also works as well. However, that's still guessing and checking for most of these. Whenever you get experienced with the factoring, this way, I found that was particularly the fastest way. Boxes is more for visual purposes. So if you're more of a visual person, that's when you would use the box method. However, the AC method will be universally more appropriate for a lot of kids because it's more constructive. So let's say supposedly I had something like this question, 2b squared plus 17b plus 21. So this here, a is not equal to 1. So what would you do? Well, you can still open up to parentheses, like this. And you can still try to find two factors that multiplies to give you 21. However, the factors that multiplies to give you the c value cannot add to give you the b value at this particular case because there's a little 2 in here. This 2 changes the game because even if you were to do 7, 3, or 21 and 1, no matter how you do it, that will not add to give you 17. These two will give you just 10 and 22. So neither of them would work if you technically think about it by using the very first steps that I've taken, that I've told you. So the way to do it is that you also have to take in consideration of this 2 that's here. There's 2 that's here. So when I'm factoring something like this, I go 2b and b, I open up two parentheses, and I'm still going to be using those two factors regardless. It has to be either 7, 3, or 21 and 1. But here's what I do. First, I consider the outside and the inside, and I first plug it in. Let's say I do 3 and 7 like this, and they both have to be plus because you see how this has to be positive as well as this has to be positive. Two factors that multiplies to give you also a positive number, but also adds to give you a positive number can only mean that these two signs has to be positive. Now I do the inner portion, gives you 7b. Outer portion gives you 6b. So what do I have? 6b plus 7b equals 13b, which is not the same as the 17b, which is what you're looking for with the b value, right? So I go back and I erase them. And then I have to try something again. Maybe I have to switch the orders for those guys because 21 and 1, 21 is just too big for me to make it up into 17. So only option that I have for it is going to be 3 and 7. So I write 3 this way and 7 this way. And now when you try it that way, I'm going to have 3 times b when I'm foiling the inside. Outside will be 14 times b. So when I add 3b plus 14b, I get a 17b. So I know that my factor here was correct. But this involves a lot of error and plugging in, and there's checking. So if this worked out pretty well because I only have two factors, but if the c value turns out to be 24, where there's a lot of factors going on to check and guess, then it's really not ethical for you to use this. Yes, this will be the fastest way to approach it, but it's not the most constructive way to approach a question like this. So, rewriting the question, the AC method works 100% of the time. Well, not 100% of the time if we say it's not factorable, but as long as it's factorable, it should work out 100% of the time. The AC method came from the fact that it's the A value times C value, and this is what you're going to do as your number one step. So the A value here is 2, C value is 21. You take those and multiply and you get 42. And afterwards, what you're going to do with that is you're going to find the two factors that multiply to give you AC, which is right now currently 42. And then you find those two numbers, two factors of that also adds to give you 17. So this is what you're looking at when you're considering the two factors that adds to give you the b value. So 42, 6 and 7, 2 and 21, 14 and 3, all these, and 4 and 42, all these numbers are factors of 42. And this one is the only one that can add to give you 17. So then I know that I'm going to separate the middle portion. So 2b squared plus 17b plus 42. I'm going to separate this so that I can have the factor by grouping. So here I'm going to separate it into plus 14b plus 3b plus 42. Now instead of splitting it up this way, where I took the 3b first instead, the reason why you don't want to do this is because we are always grouping the first two and the last two. And as you take a look here, 2 and the 3, there's really nothing that you can factor versus this and versus the 3b along with 42. The 2b squared can go along well with 14b, and you can factor out a number from there. So it's really arbitrary. This part also involves sort of like guessing and checking, but only for the middle portion. As you practice enough through, you will get better at this when you're doing the AC grouping. So here, the reason why we don't want to group 2b squared plus 3b together is, yes, you can try it, but eventually at the end, it's not going to work out. And here's what I mean. Between 2b squared and 3b, so I'm going to erase some of these guys. So between 2b squared and 3b, the only thing you can really factor out is b. So and after that, what I'm going to do is I factor out the b. So what comes after that is 2b plus 3. Between these two, yes, you can factor out a 7. So you can get 2b plus 6. Now here's the issue. This parentheses and this parentheses, after you do your AC method, they must be the same. Otherwise, when you get to this stage, you're stuck and you can't really do anything. So that's how I know maybe you should group this guy the other way around, which is what we have here. Now, if you take a look at these two, not only can you factor out a 2, but you can also factor out a b. For these two, you can factor out a 3. So 2b out gives me b plus 7, plus 3 out gives me b plus 7. And this is what we want, for them to be the same thing. Because if I factor the b plus 7 out from here and here and here, what's left is this 2b plus 3. So I'm going to put that in one parenthesis and the other one in the other parenthesis. And that's how I factor using the AC method. And 2b plus 3 times b plus 7 should be the same as the one we had way up here, right? When we're just doing guessing and checking with those two parentheses. So the AC method, like I said, it's a lot more work, but it's very constructive in which how you can solve the problem. So it will work out. As long as it's factorable, it should work out 100% of the time. This is how you'll be doing the AC method. So we talked about factoring trinomials when a is equal to 1 versus a is not equal to 1. And that's when you would pretty much have to use the AC method for most of those cases. Now, let's talk about completing the square. Complete the square. To complete the square, I gave you guys the visual representation of some of the questions that we have. However, I am going to go over some of the questions that we had on the homework. One of those looks something like this. Now, the visual representation of completing the square, the reason why it's called completing the square is that we can express something like this into this. Some sort of a quadrilateral shape that's missing this last portion, and this is what you're really trying to solve for. Now, if I were to call this length as x and this length as x, you would have the area of this square box to be x squared. And hence, because we want to complete this as a square, the side length from here to here has to be the same as the side length from here to there. So, what goes here and here? Well, because this side I know is x, this times this, and this also is x, so this times that, which is the same thing. These two area has to be the same amount. And these two, because they both have x's in them, they have to combine to give you this middle guy, which says 6x. So it would make sense that this would be the half of 6x, and this will be the other half of 6x. So if I were to redraw that square, this would be x squared because this is x and this is x. But this would be 3x and this would be 3x. And by adding these two portions up, you would get 6x in the middle. So the length of this has to be a 3, and this length has to be a 3 because the rectangle area is just length times width. So x times 3 is 3x, and another x times 3 is 3x. That will tell you what this last number is going to be. because this last number here is going to be 9. The length from here to here is 3. The length from here to here is 3 based on these numbers that we have figured out. So what we're trying to do is we're going to add the 9. And so you can factor this out really easily. Yet, however, we're forgetting the fact that there's an 8 in here. So in order for 9 to go to 8, we must make sure that this has to be subtracted by 1, so that if I were to group these two first together, this would be the same as the original. I am just separating the 8 into 9 minus 1 equals to 0. After you figure that number out, it's going to be a simple math. Add the 1 to both sides first. X squared plus 6x plus 9 is equal to 1. Then this is factorable because it's simply x plus 3 times another x plus 3. So this will be x plus 3 squared is equal to 1. After that, you would have to square root both sides to cancel out the squared and the square root. Plus 3 is equal to, don't forget your plus and minus 1 on the side. Then you would have to subtract the 3 on both sides, and you will get x equals negative 3 plus and minus 1. So your two answers will be negative 3 plus 1, x equals negative 3 minus 1. Hence, that will be negative 2 and negative 4. This answer will be the same when you decide to factor this. X squared plus 6x plus 8 is equal to 0 means that you can factor it this way, and you can still solve for it. Very, very simple if you decide to factor. So when a question like this comes along, you definitely want to try factoring rather than doing all this work for completing the square. Remember, if the question doesn't ask you to complete the square and asks you to solve the equation, you're free to choose whichever method that you feel more comfortable with. However, you also should pick the one that saves you a lot of time, and for a habit of when you're doing the standardized testing, any single time when you see that it's factorable, then you have to factor it. You must factor it because that will give you the answer right away. Now, let's try something that's actually a lot more complicated. We tried factoring, or we tried completing the square where a is equal to 1. That was a really easy example. But let's try something where a is not equal to 1. So for example, let's say 20. On your homework, 20x squared minus 5x plus 67 is equal to 0. Now this was the homework problem that had a worksheet up until question 24, and this was all strictly just talking about completing the square. When you have an a value as 2, your first step is always to get a is equal to 1. Because if you're trying to complete the square, this first square has to be x squared in order for this length and this length to be the same. If this was 2x squared, you must make this to 2x and 2x. Or, I'm sorry, 2x and x. Which by that definition already, this length from here to here will be double this length. So it won't be a square any longer. It's not going to be square any longer. So in order to avoid this problem, this 2 must disappear. So a has to be 1. That's your first step. However, on the second day that I told you about completing the square, what we have discussed was that the very first thing, even before that, what we should do is to move the c, the constant value, to the other side. So you have all the x's on one side. So in order to do that, you have to move the 67 to the other side by subtracting them and get 2x squared minus 5x is equal to negative 67. Notice how I leave myself a little space here and here because I'm going to add something to here and here. Now you take a look at the step number 1 that we created. So if you want to think of it this way, the step 0 will be move every number to one side, the 67, and keep all the x's onto the other side. Now after this, what you're going to do is you're going to make sure that your a value is 1. To get rid of this 2, you have to get everything divided by 2, not only on the left-hand side, but also on the right-hand side. once we do that, the a cancels out, but that doesn't mean it cancels out completely with the 2 because this also goes with the 5, like this, is equal to negative 67 over 2. Now, the second step that we always must consider is, remember on the very first visual example that we had, we took this 6x and we split it in half because it's half of 6x, and we get 3x and 3x here. That's what we added to those two. That's what we added to the square of x squared on the side and the bottom. Because we have to half it, half here and half here, we always must half our b value, just like how we halved the 6x and got 3x and 3x. So what is half of the b value in this particular example? Well, b value currently is negative 5 over 2. So if I were to halve the negative 5 over 2, it would be negative 5 over 2 divided by 2, or the same thing as saying negative 5 over 2 times 1/2, which is negative 5 over 4. Now, what am I going to do with that, and why is this important? It's because later down when we factor it, this is the number that you should put in the parentheses. Now, the third step would be to take that value, negative 5 over 4, whatever you have gotten, and you have to square it. So take this, and you have to square it. So negative 5 over 4 squared means it's 25 over 16, and it must be positive. That's why we always say that we are adding to both sides, because when you square any number, you should always get a positive number. It always makes it positive. So that's what we're going to add to that little blank spaces that we had marked in red here and here. So rewriting it, x squared minus 5 over 2x plus 25 over 16 is equal to negative 67 over 2 plus 25 over 16. And so this is what you should have so far. Now here, that's what I talked about, this goes in the parentheses. When you factor this out, it simply becomes x minus 5 over 4. I'm just going to rewrite it. X minus 5 over 4. That's it. Because if you FOIL this out, the last portion will be the same thing as saying negative 5 over 4 times negative 5 over 4, which is negative 5 over 4 squared. We already did that for our number 3 step. And that's how we got this number. And when you do the first, outer, inner, last, you would go back up to what we had originally. Now this is the whole thing is equal to negative 67 over 2 plus 25 over 16. That doesn't change, but this is adding a fraction. When you're adding fractions, the first thing you need to have is common denominator. So to have a common denominator between 2 and 16, it should make sense that this 2 has to be turned into 16. So in order to do that, I need to take this fraction and multiply by a form of 1. So I don't change the number. I do not want to change the number. Anything multiplied by 1, it's just by itself. So how am I going to alternate this 1? Well, I'm going to change this to 8 over 8 because the reason why we want it as 8 over 8 and not anything else is because if I multiply this through, the denominator becomes what I want, which is 16. 67 times 8 should give you negative 536. Please, for some of you guys, this is your worst nightmare, but that negative sign makes the world of difference between incorrect and correct answers. So, continuing through, what we have is x minus 5 over 4 squared is equal to negative 536 over 16 plus, don't forget your 25 over 16 here. And when you add these two together, you should get negative 511 over 16, x minus 5 over 4 squared. Now it looks a lot simpler to work with, and then after that, this part didn't change with the square rooting both sides. So x minus 5 over 4 is equal to plus and minus, please don't forget. Please don't forget. And then square root of negative 511 over 16. Now some of you guys wrote it like this. There's a huge difference between the two. Make sure the square roots go all the way through. Afterwards, this right here in the denominator is doable. What I mean by that is it's plus and minus the square root of negative 511 over square root of 16. I can separate this one gigantic square root into two separate square roots like that, because it wouldn't change the number. X minus 5 over 4 is equal to. Yes, keep on writing this down so that you don't lose track of where it is. Then afterwards, square root of 16, you and I both know that that's 4. Square root of negative 511 stays on top because I really don't know what that is, or you can't compute it by hand. And x minus 5 over 4 is equal to that. And all you got to do is just add the 5 over 4 on both sides. And what you're going to get is x is equal to 5 over 4 plus and minus the square root of negative 511 over 4. And this will be your final answer. Yes, you can rewrite it as this because you can combine the correct same denominator on the bottom. Luckily, it turned out to be that way. But this answer is also good too. Either one is okay. So, completing the square, there are 3 steps. Number 1, or 4 steps if you technically count the fact that you need to move every number to the one side. Or so generally speaking, get it into this format. Ax squared plus bx is equal to c. Once you have it in that format, then you do 3 steps. Number 1, keep the a value to be 1 by dividing away. Divide away the a to both sides. Don't forget to do it on both sides. Then you take the half of the b value, then you square it, and then you add that number to both sides. And then once after that's finished, all you have to do after that is going to be simple algebra where you have to just compute the number and then square root both sides. Square root both sides, and then get your final answer in the most simplified form as possible. Either this one or this one would do. Now, after talking about completing the square, then we can talk about quadratic formula, because the quadratic formula really came from the completing the square. Suppose I give you ax squared plus bx plus c is equal to 0, and I ask you to solve for that. Now, the reason why I give it to you in this format is because if a is anything, and b is anything, and c is anything, any number, any real number that you could think of, or any integer number you could think of for that matter, it doesn't matter whatever you plug in as long as it's real. And once I solve for that using the completing the square, then that basically gives birth to quadratic formula. And so quadratic formula is just the formula that you memorize, but also at the same time it's a derivative of completing the square. So no matter what, you should always be able to solve for the solution by using completing the square, and also by using the quadratic formula. It doesn't matter either way. So here's what we're going to do. We're still going to use the same 3 steps or 4 steps. The very first thing by moving the c away. Notice how I gave myself a little space in here and here. Always leave yourself a little space. Then my first step was to get rid of a, or keep a value as 1. Now, yes, you guys might argue with me that a could be 1. Could be 1. Yes, a could be 1, but I never said that it was going to be 1, nor that there's a higher chance that a is something else other than 1. I mean, it could be 2, 3, 4 to infinity, negative 2, negative 3 to negative infinity. There are actually infinite amount of possibilities, and this is just one of those possibilities, which that means the chance of that might be 1 is very, very tiny. So, you cannot assume that a is equal to 1 because I didn't tell you that it's a is equal to 1. So, you need to keep a is equal to 1, even if a is something that's not equal to 1. How do I do that? Just divide everything by a, just like how we did before. If I divide this side by a and this side by a, this becomes this, and this becomes that. This a has to be applied to both the x squared as well as the bx. And that's where we have what we have so far. Now afterwards, the second step was to have our b value. So let's half the b value. Once I have the b value, it's b over a. Currently, the b value is b over a. Then I half that, which is the same thing as saying b over a times 1/2, gives you b over 2a. The third step, square it. Square whatever you've gotten. So that b over 2a squared means it's this whole thing squared. Same thing as saying b over 2a times b over 2a. Please do not say b squared over 2a squared. It should be b squared over 4a squared because that's 2 times 2 as well. That would be what you're going to be adding to both left hand and right hand side. Rewriting this equation, it will be looking like this afterwards. So I just copied the one in black down here. The thing that goes into this red blanks is going to be b squared plus b squared over 4a squared. So remember this number, this step 2, this is a number that belongs in the parentheses down here when we factor this. So it's going to be x plus b over 2a squared. This is always going to be the number that you got from step 2. Memorize, keep that in mind. Then this is going to equal negative c over a plus b squared over 4a squared. Now, this here, you can simplify it by getting a common denominator. Remember, from the example that I've given you up here, I added the fraction by doing the common denominator in blue. I took a look at the fractions and I found the common denominator. Just because they're letters doesn't mean that you can't find the common denominator. Between a and 4a squared, the common denominator would be this. Just like between 2 and 16, the bigger one or the larger number was usually the common denominator. And it happens so that it's very easy for me to get to 16 when I just multiply by 8. So what do I multiply to a to get a 4a squared? 4a. So I'm going to multiply negative c over a by a form of 1. Negative c over a times 4a over 4a, which gives you negative 4 times a times c, keep it in alphabetical order, over 4a squared. So my final answer for that, if I rewrite this part, becomes negative 4ac over 4a squared plus b squared over 4a squared, which simplifies to finally b squared minus 4ac, I'm just switching the order, over 4a squared. Now this whole thing equals, bringing this down, x plus b over 2a squared. Now then, after that, what the step that we took was square root both sides. Cancel these guys out. This becomes x plus b over 2a is equal to, don't forget your plus and minus. Please don't forget. Square root of b squared minus 4ac over 4a squared. Now, because this is redoable like that, by splitting up into 2 like this, this is simplified into 2a. Because we know that 2a times 2a gives you 4a squared, so square rooting that just gives you one of these guys. So it's plus and minus the square root of b squared minus 4ac all over 2a. And this is equal to x plus b over 2a. Just bringing this down again. Now, the final step, just move the negative b, plus b over 2a by subtracting that. So x equals negative b over 2a plus and minus the square root of b squared minus 4ac all over 2a. Then, because they have a common denominator, I can combine those two together and get this. So, no matter what the a value may be, what the b value may be, what the c value may be, you're just going to plug into this value for b, a here, and c here, and you will get your answer. So, let's try to check to see if we can get the same answer as we did before. The answer we got was this thing when we completed the square. The example that we have used is 2x squared minus 5x plus 67. So I'm going to rewrite that example and see if I'm going to get the same answer. 2x squared minus 5x plus 67. In this case, my a value, I'm going to write it in red, A value will be 2, B value will be negative 5, C value will be 67. So I'm going to take these and plug it into my quadratic formula. Negative 5 plus and minus the square root of negative 5 squared minus 4 times 2 times 67 all over 2 times 2. This translates to, these are two negatives, so it's going to be positive 5 plus and minus the square root of 25, negative 5 squared, minus 8 times, this is going to be 8, so 8 times 67 gives you 6, 5, so it's 536 all over 2 times 2, which is 4. So it's equal to 5 plus and minus the square root of negative 511 over 4. And lo and behold, that same number is what we got when we did up here. So we made connections with completing the square, and we elaborated that to get the quadratic formula. Everything should be related. Whenever I give you a quadratic equation to solve, solving means to solve for the x. And you can use 3 methods: factoring, quadratic formula, or complete the square. I do recommend number 1 first because it's the fastest way to get the solution. When I ask you to factor something, I'm asking you to get into this format. Please do not solve. I would not even say that this is equal to 0. I never said that. So you just leave it like this, and that's what it means to factor. So there's also factoring when it's like this. You have to factor out the 5k out and say k minus 4, because the 5k is common, the greatest common factor between here and here. Even if I were to give you 5k squared minus 20, it will be 5 times k squared minus 20. Please don't write down k squared minus 20. The 5 doesn't disappear. The 5 has to be in there. This was a common recurring mistake that I've seen. So, greatest common factor, you should already know how to factor that out. This is also a greatest common factor, but just because they're just number, and that just means that you can cancel out. If you are solving for it, however, that's a different story, because you can just divide away the 5 on both sides. The 5 will disappear from there. Okay?